Hello everyone, welcome back. In this tutorial, we will pick up where we left off in our previous video. We were basically trying to make our helix accommodate to our viewing pod, which is to say we will try to make the script respond to where the viewing pod is and simply make the helix modify itself by making that hole possible, as you can see in this picture. In the last video, we were able to cut this part of the helix, and we're going to pick up from that. It might be useful to isolate the inner helix first, which is actually, because I'm in render mode, what you see is what it will, the render will render everything that it has a material to it. So if I disable this plugin, it will be going away, even though this is not enabled, because I'm in the render mode viewport. Alright, with that deselected, so we can now focus on our major helix, or the outer helix, the blue one. In the last video, we were able to come as far as making this culling happen, meaning to get away the bits or the section of the helix which is interfering with our viewing pod. And the two parts that we still need to complete for this modification of the bridge of the helices is actually making that part happen, which just goes down to our horizontal beam, and connecting this part here to the other major helix, and that stems actually from the point that's in the middle from this looking upwards. So that's what we're going to tackle. But first, let's do the small bit first on the side. Okay. From the last video, you should have points that that make the shadowing happen and make that section happen to disappear. And I think it's that component, those 12 points, right? Since we have only two branches, because only two of these helices were actually interfering, so those were actually the only ones that has to be shattered. So let's keep that open. What we can do is we can say let's find those top points first, and then once we have those top points, I wanted to look at the closest point that's on the bottom and take that point and just make that line connect those 2 points into a line, and there we have it. So the first step being, we need to find which of these 3 points or which of these 4 points do we need. And one way to find that is to actually sort them by their heights. Well, what I like to do is actually fork away from this so that we can have this component to work with. We know that this component will be responsible for what we want to achieve. So if something goes wrong, we can just come here and diagnose from this point on. It's just much easier. So we can say, let's deconstruct a point. And we have the z-axis now. We can sort them according to their z values. And if you open up a panel, you should see the points that we should have. Let's look at the distances. So these are the distances in terms of the z value. The ones that we obviously need is going to be the highest. In this case is the number 4 and 5. The 0 represent that they're actually, in terms of the coordinate system of our project, they're at the 0 point, which makes sense because I think this is also where our initial curve is located. So our bridge is actually all the way under the normal plane. But that shouldn't make sense. That shouldn't worry us, because whatever point is at the last number is always going to be the highest. Doesn't matter if they're positive or negative, because the sorting system always takes the negative values into account. So what we can do is we can select these items using a list item. But in our case, we have 2 branches. So it's easy to see that we need to select the last 2 items. But what if for some reason our bridge is longer and we have 3 branches? What then? in order to accommodate those kind of unforeseen changes, what we want to do is simply flatten our points. That way, we will always know we just want the last 4 items. And I say 4, and that 4 ties back to we have 4 support structure. That's why we have 4 parts of our helix that should be shattered. So where can we get the number 4? Well, we can actually get it from here in the beginning, which is a geometry that we use in order to even make this hole happen. So what we're going to do is we're going to do a list length from, it can be either of these, it really doesn't matter, but I'm taking it from this because we know that we have to flatten these solids in order for our Boolean operation to take place. So I can actually cut it from there, drag it a bit here. So now that we have the number 4, what we can do is we're going to make up a series, and it can start from 0, stepping of 1, and the number in the series should be 4, so that we have these numbers. We can use that in our index of our list item to select the items that we want. So let's do that, and the items that we want to select is not the k, because that's just a number of heights, but actually the point. But now we've selected actually the most bottom points. There are 2 things we can do to remedy this situation, which is first, you can either reverse the A or reverse the L. Doesn't matter which one you reverse, just make sure you don't do both, because then it's like a double negative, then you won't be doing anything. So I'm going to reverse the L of this one, so that I'm always selecting the last from the list. And there we go. There we have our 4 points. Now, the next thing we need is to find a point that is actually corresponding to this point here. And let's close that one. What we can do is we can take the endpoints of the I-beam, and use those points instead, and then we can say find the 4 points, or find the 1 point that's closest to each of these points, and that's going to be our result. So let's do that. I don't think we have an I-beam selected here, but we do have it here that is used here. Yeah, so let's copy that and Control Shift paste, Control Shift V to paste that. Let me see. This one has an entwine. Do I need an entwine? Doesn't really matter. Well, we can keep the entwine actually. It's the same thing, because in the end, what we're gonna do is we're gonna flatten the whole list, because we don't know which point it needs, right? I mean, who's to say that that point number 1 isn't on the side that we want or on the other side? So it really doesn't matter whether you use a merge or entwine, because we'll be flattening that anyway. So the next point is to find, I think, closest point is what we want to find. Closest point, that one. I think P point to search from, that's the cloud, and the point to search from is actually these. And now we can do a line from here to here. There we go. We can actually hide that. For this, let's use an entwine. Or actually, we already have a merge. Why not use the merge, right? Yeah, let's do that instead. So this one goes in, oh, what? Oh, okay. This one goes there. Hide that. And we have our section. The next part is to make the bridge happen. Now, the easiest way to do that is to simply say, let's take that point, and it goes from there linearly in one line. But that's not always what happens, because if you look at the pictures, it's actually curved. So we need to find a third point, in our case the middle point, that will define that curvature, and the curvature actually follows the same circle that we used for our outer helices. So that's what we're gonna do. But first, let's find that point first, that imaginary point that we need in order to define the both lengths of that curved section. As I said, we can actually say, let's find it based on that middle point, going up and see what point is there in the vicinity that we can find. So let's try to model that logic. I think we have the points already for our curves. So we're actually visually, in our eyes, we can see, okay, we know exactly which point we want. But in order to tell it to Grasshopper so that it can find that point for all the other ones, and when our helix change, it should still find the same point, we should define that logic. But first we have that, so we are just going to let's fork this off. Even though it's the same thing, it's just going to be easier for us down working somewhere all the way in the end, so we can pick it also quite easily. Okay, we have that point, the one end of the point actually. I think it's this one. This one. Yeah, that one. And we also have the middle point, don't we? That one. Now, this is where we actually want the other way around. So, what can we do? The simplest way is we've defined the logic behind these 3 points anyway, so we can just take that and flip it over. That way we have the middle points, that one, the ones that we want. 4 points. Now, how can we make these two work with each other? You know what? Let's do like this. Let's draw a line that goes up, and then at the end of the line is a point where it should search for a point that's in the vicinity to connect to. So judge from this, it should go in the direction upwards, which is the z-axis. And the length, well, it cannot be this short, because if it's this short, then it can find a lot of different points. So we should help Grasshopper a bit in order to find that point. And what I think we should do is, let's have a look at if we can use some type of logic in this. No, not that one. I don't know where it is. Let's disable that for now. Okay, it's this one. How about we say, let's use either the height or the length of that, and twice. This should give us approximately where we would want it to be, right? So we can try that. Let's go back in. Let's see what the length is of this thing. 2.7, 2.8 almost. Wait, hold on a minute. 2.7, 2.8, isn't that the section length that we have? Which is not, oh here, distance between the eye beams. Maybe we can use that? Or is that purely coincidental? Interesting. Well, we can actually use that. In terms of the distance, that cannot change very drastically, can it? Because if this changes in height or in length, then it means that the whole sort of helix will be squeezed in the height direction, so it should also go with it. So I think we can safely actually use that. What we're gonna do is, let's do a multiplication. Oh, not this one, of course. Let's do a multiplication by, let's multiply its length by a number and we're just gonna call this 2 because we know we're gonna multiply by 2, and that's gonna be the length of our line. Oh, that's very close, even though it's not per se that point, but it's very close, which leads me to wonder, maybe it's 2.7. Oh wait, 2.7 doesn't have any logical meaning here, so let's give it a name. um let's say uh, search height, uh, search helping, search helper, something like that. Modify. You can say search helper, but if you look at where it's connected, you should know that it's a multiplication. So depends on how long you want this to be in order to make it, in order for it to make sense to you in the future when you come back to your script. And you're like, what does that do? So now that we have this, we can say let's do a ZRV evaluation. Since it's stored there, we can safely say we parameterize it, and number 1, which is going to be the end, is always going to be the top. If we zoom out a bit, you can confirm that it's always the top. And now we can flatten this whole list because we wanted to search for this whole list of points. It's a bit too much. You can actually, before this, you can, after this, you can put in a filtering process that filter only the points that you want, which is perfectly doable. But I don't think that costs a lot of computational power versus the time we need to make that also happen. But it's a good exercise if you want to go that route. It adds a bit more complexity to your script, but it also more stability in the sense that you know exactly what steps are being taken to ensure that you have the correct data. Okay, with that said, let's find point closest. Do we have it here that I can just connect or copy? That one. That's the cloud. These are the points. There we go. Let's move this a bit to the back. So now that we have this point, which is on the curve, let's visualize it by doing the exact same thing that I said that we won't be doing. I think this one is our last one. Oh no, wait. This point? No, that point. Yeah. Oh right. The ordering is simply messed up. Oh, that's a different thing that we need to tackle. That's interesting. So we need to fix that. The ordering of the point. Well, a very easy solution is actually just from this point on, you basically say, I want to search the closest point from the cloud of these 4 points, which will give you that correct answer, because we anticipate that these viewing pods are not going to be neck and neck close to each other, where the closest point of this can be that point. In a scenario where you have, let's say, oh wow, let's say let's say you have this here, and the next one is like, I don't know, here, then the possibility of it selecting that point exists. But then you have this overlapping here that probably won't happen. So this here ensures that the next viewing part, if you do want to do that, is going to be here, which point will be here, and that distance cannot beat this distance. So from our logic of things that cannot happen, from our reasoning, we can safely use this. That is the fastest way to make this happen. The other one being that we have to come in here and redo redo this selection here, which I think could be sort the point by their sort the point first along a curve, which can be the curve of the main bridge, the main curve actually, or find some other way to sort these points into nice little groups of 3, and then resort that back into their according to the heights. For example, that is one of the things that can work. Or like I've maybe mentioned, that you can make use of these integers that you've first identified and um, picked up, filter out, because those are already in the correct group. It's just that they're on the same curve that we've used the trim tree to flatten it back down. But that's in the scenario that if you really do want this to happen, or if you have like just not this kind of viewing pods, but like super small viewing pods, for example. But it can be maybe a discussion or the topic of another video in order to make the Helix Bridge some sort of like Helix Bridge generator, where you can modify basically any aspect of this that can differ immensely from the original. But this is what we can do for now. So let's set that up. This is exactly what we don't want. So we need a third point in the middle in order to make the curvature happen. What we can do is we can just say CRV evaluation is where is it? CRV evaluation is here. Let's parameterize that, and then 0.5. They should give us a center point, which I'm actually curious, is that also the center point of our I-beams? Rendered? Which is, of course, because, yeah, well, it's close to it. I can't say for sure that it is, but it is close to it. But that's all we need for this, because we just need this point in order for us to find the real point that we want is actually not this one. It's actually the ones that are based on, if we go back all the way back to our main circles. Not sure we made it here, but we definitely made it here. Main circles. This one. It should actually be based on this circle. So looking from this, what we can do now is, can we copy this over? Have I used a main circle here somewhere? Doesn't look like it, no. Main points, but not circles. Okay. Alright, then we'll just make our own, I guess. Or we can, since this is actually so far in the beginning, we might just wanna make this into a parameter that we can just copy paste. So we'll just do that instead. What are we gonna call this? We're gonna call this outer helix circles. Perhaps makes sense. Yeah, makes perfect sense. Yeah, let's add that to the group and drag it all the way to there. Hide it and give it a name. And we can copy this all the way here. That's it. Okay. Let's find the circles that we want by using point closest to curve. Point closest to curve. These are the curves that we want to evaluate to from our points that are in the middle here. Okay. Actually, can we actually select? Because now we have the points, but oh wait, I need to do graphs, because each point should evaluate to each circle, so that I can always select the right circle. Okay, so what we're gonna do is say sort their distances by circles. And if I do a list item on the first item, which should be the closest, is always going to be the circle that I need, which are these. And now that I have that going for us, or actually I don't even need to do that. I just need to do okay, let's add another one. Let's see if that works. If I do this, I should just have the point. I mean, the circle is nice, but I actually want the point, not the other way around. I don't need this. And now I can be sure that this point right here is sitting right on our circle. And we can actually visualize that briefly by looking at that. There we go. And now we can just do a merge. Starting from, let's start from the bottom one, which is this one. And then the middle one. One thing we're not sure is the ordering, but we'll see how that goes. It should be fine because they all come from the same source. So let's put our, one of them needs to be grafted. This one needs to be grafted. Yeah. Flattened, sorry. Or actually, all of them needs to be grafted, to be honest. Let's simplify this and, you know, no. Let's simplify that and graph the rest and also simplify them if they're not already simplified, because I want them to be in the same branch level. So let's do that. You know what, let's just do it here so we can have something as orderly as possible. Okay, one branch for 3 items per branch. Now we can do an interpolate, the moment of truth. Oh, there you go. Let's disable that and put this together with our other merges so that we can have our beam. That's one. We already did end. Number 2, number 3, and of course number 4. Okay, that's it for the modification that we need to do for the major helix. The simplest way to do for the minor helix is, let's turn that back on. Oh, make that. Is we can just copy and paste this whole thing and then paste it for the minor helix. That's the easiest way to do. So maybe you can just do that and see how that works out. Alright, let's start by, you know what, let's just duplicate the whole thing. And then now we can come here and see what we need to change, etc, etc. Obviously this will have to be changed. The I-beams can stay. Boolean geometry can also stay. The outer helix point will obviously be the inner helix points, which I don't have it here because I haven't created yet. Okay. Let's copy it from here. I think these are the points. That one can go there, and this one will be named inner helix points. So rename that also. This can stay outside because we can use it as a copying machine. Like that. It needs to be simplified because it's just cleaner that way. Let's do the same. Let's drag all this for here. I can delete that safely. Oh, it has also turned blue because, oh, we're using the same blue. Let's copy this then, and did we turn that off or did we, oh, we just removed it entirely. Okay, did we? Huh. Okay, let's copy that then and paste it here. We only need the color. Yeah, we only need the color. Or actually, we don't need that color. So we can delete that, we can delete this, we can also delete that. And I believe this one is now obsolete. So we can delete that also. Hey, what do you know? That part worked. That part worked for us very nicely. Let's have a look at like a random viewing part. Let's say the third. I mean, obviously this is wrong. That looks actually quite funny. Obviously this is wrong because it's taking the curvature of the big circle, which is not the case in our, because we wanted to take it from not this circle, I believe it's the smaller circle, which I think it's this one. Let's see, which is the parameter 5.4. It is this one. But why is it so big? Oh no, it's not 5.4. It should be 4 point something else. It should be this one instead. But I'm not sure why it doesn't look that way. Or I'm just confused. Inner helix diameter, yeah, it is this one. So we can do the same thing here. Copy it over to this one. Add this to the group, and then we call it inner circle. These can come in here and like that. Let's hide the lines. Now I can copy that one, put it here, and transfer that to here, and close that, disable that, and let's have a look at our results. It's still taking the wrong one, or am I taking the wrong curve? To be honest, I do have a feeling that I'm taking not the right one, because that circle looks way too big, to be honest. It is this one instead, but oh, it's been moved to the bottom. I needed it to be moved. Well, actually this one is what I need, not this one, because this one is still the one that is just slightly smaller. So we can actually fix that really quickly by, doesn't matter which one you take, this one or this one. I'll take this one. This one I'm gonna move it to that one. There we go, fixed. Looks more natural. See, that's the power of creating the logic that can be adapted to um, different inputs that expect the same or relatively the same data. And with that, we just completed both our helices that can encompass filling pot holes. As easy as that. Okay, and well, is there anything else that will take this? You know what? Let's do it. Let's copy the names over, and we'll copy the names over too. Yeah. Put that here. Put this here. You know what? You can just call it modified, perhaps. Modified. There we go. And I'm also going to take the same color for that part. So I'm just going to group that. Move this a bit away. We're going to make this default and group this. There we go. This one, let's give it a slightly different color in order to make it stand out from the rest. Anyway, all right. That's it for this tutorial, or at least for this for this part. Not tutorial. There's still one last thing we need to tackle, which are these all these interconnected rods between all the major tubes: the inner helix, the outer helix, the horizontal tubes, the belly of the bridge. So that's going to be interesting to look at in the next video, and I believe that will also be the last section of the tutorial where I'm going to show you how to do. You may notice I'm not doing the glass that you can see here. I think this will probably either end up in a separate tutorial series where I show you some sort of a continuation from this, but this is meant to be actually just for the bridge structure itself and not per se the glass of it. And you may also notice that I am not doing that part. I think in the third support structure where it also connects to a speedway, a highway on the other side. So that is also taken outside this consideration into this outside of this tutorial series. So the only thing we're going to be tackling next is actually all the interconnecting in between support rods. So that's going to be interesting. And until then, have a great one. I'll see you in the next video.